some minerals here.
I have a question.
What's your question?
What is a mineral?
What is a mineral? Well, we've been talking about rocks, and we learned some things about rocks. Things like they're solid and they're non-living, meaning they don't eat, sleep, drink, or walk around. Nature makes them. And rocks are made up of one or more mineral. So if rocks are made up of minerals, what are minerals made up of?
Yeah, what are minerals made up of?
Well, they're made up of these things called elements. You guys know that the universe is made up of this stuff that's all around us called matter, right?
Yes.
And matter is made up of elements. You actually know some elements. Water is made up of two basic elements. Do you know what those are?
I do.
What are
Hydrogen
they? H.
and oxygen.
O. So what's the science way of saying water?
H2O. Oh, and I know it looks like Mickey Mouse. The O is bigger and the H's look like his ears.
Yeah.
H2O.
Yeah. So when you guys get a little older and you get in middle school, you'll start learning about a science chart that looks like this, called the periodic table of elements.
You'll look at it periodically.
These are all of the elements that have been discovered in nature, and a few that have been made by scientists.
Yeah, the ones down here, right, are
Yeah.
the ones that have been made by
But you
people.
actually know a lot of these, and the letters are like abbreviations for them. So C is carbon,
That's right here.
N is nitrogen.
And right there.
Right next to it is O. What's O again?
Oxygen.
Oh my goodness, it's oxygen. See what I did there?
And there's H.
Oh,
the other
H.
one in water.
For hydrogen. If you ever go to a birthday party and you do the balloon thing and you talk really high when you breathe in some helium.
You never did that.
Never.
It's not good for you.
Now, sometimes we have elements that start with the same letter, so it gets a little confusing. So, what language did they use to figure this out?
Ooh, Latin.
Latin. So, certain elements, like here we have silver is Ag.
Yes. And gold is AU.
There it is. Au. It's gold.
AU, it's gold.
Check it out.
That comes from Latin. too.
Yeah.
And
yeah.
lead.
Yeah.
And the PB.
PB. Yeah.
Yeah, it's where our word for plumber comes from too.
See, I didn't even know that. Wow. So anyway, these are all the elements. So minerals are nothing more than either one element or a combination of elements that come together as a solid.
Groovy.
Yeah.
That's what a mineral is.
That's what a mineral is. Let's look at a few examples of some solid elements. This is the element sulfur. That's all it is, solid sulfur. You scratch sulfur and smell it, it smells like something.
Ugh, smells like eggies that
Yeah.
aren't so fresh.
Rotten eggs, yeah, a little bit like that. Copper, Cu. Copper is another example of just one element that's a solid. It's copper. But typically, minerals are combinations of multiple elements.
How do you,
Solids.
so how do you tell them apart?
Yeah, so that's the thing, right? So there's over 2,000 known minerals that have been discovered on the Earth. 2,000. But only about 40 of them are very common, ones that we find a lot. And so geologists, scientists that study rocks and minerals, have sort of figured out that minerals have some unique things about them that help you tell them apart. They're called
Properties.
properties, yeah. So we can look at some different kinds of minerals and use some of their properties to figure them out. So maybe we should talk about some properties.
Maybe we should. Maybe I'll let you do that.
Oh.
Since you're the expert geologist guy.
You're a pretty smart person yourself, but
I am, but somebody's got to hold the camera.
okay.
Okay, so let's do that. You can talk about the properties and I'll hold the camera so I can zoom right in while you're doing that.
Okay.
All right.
Sounds good.
I'll be right back.
And you can banter from behind the camera.
Well, you just bantered into my introduction.
Oh, sorry.
Hello, Back with my geologist expert person who's going to tell us about the properties of minerals.
Yes.
So let's go.
A long time ago, there was this geologist whose last name was Moe, M-O-H, Mr. Moe. And one of the things he noticed, probably Dr. Moe.
I was going to say, yeah, probably Dr. Moe.
Not to be confused with Moe, Curly, and Larry of the Three Stooges.
Hey, Moe.
Hey, Moe. But anyway, Moe noticed that, certain minerals are really hard, whereas others are kind of soft. And so he came up with this scale called Mohs scale of hardness.
Oh, let me zoom in and get that. Ooh.
This is a neat picture showing some minerals on Mohs scale of hardness. And what hardness is, it's the ability of one mineral to scratch another, right? And so it goes from number 1 over here all the way over to number 10. 1 being the softest, and one of the softest minerals we know of is something called talc, which we'll look at in a second. And the hardest known substance in the Earth's crust that we've discovered is a diamond. So diamond is 10 on Mohs scale. So 1 soft, 10 really hard, and gets harder as you go up the scale. So here we have talc, a fairly common mineral. And one of the things we notice about talc is it's really soft. I can use my fingernail and the flakes of powder come off of the mineral. That's how soft it is. You might have heard of talc because we use talc in baby powder, talcum powder. It's just crushed up talc in a bottle, maybe a little fragrance. Very soft. So is my fingernail harder or softer than talc? Well, it was able to easily scratch talc, so it must be harder. Another soft mineral is one that looks something like this. It probably looks black to you, but it's kind of grayish, right? But cool thing happens. I can take paper and I can actually rub this mineral on there, and it leaves lines. Let's see. Let's do this. Matt, who's that? Oh,
I don't know. That's just some guy.
some random guy. It's me. Now, I notice when I'm at school, I see this mineral all the time. This mineral is called graphite. And where I see it around the school every day, all the time, is in pencils. Yes, believe it or not, your classic number 2 pencil has graphite in it. And that's what you write with. We used to use a mineral, an element called lead, but we realized lead was not good for people. It caused cancer, so then we decided to use graphite, another soft mineral. A lot of minerals are somewhere in the middle between talc and diamond, right? Maybe medium hardness, but one of the most common minerals is quartz. Here's a cool quartz crystal. Quartz is about a 7 on Mohs scale, so that's getting pretty hard. Not as hard as a diamond, but pretty close. One of the ways to test for hardness is we use a glass plate. You have to be careful with glass plates because they could break and you could cut yourself on a sharp edge. But this is a brand new glass plate, and if I take this quartz and I rub it on here, it scratches it. I don't know if you can see that scratch.
I can. If you just hold it still a minute, I will show them. Gotcha.
Yeah. So, which is harder, the glass or the quartz?
Yeah, you can think about it as who scratches who.
Who scratches who? Exactly. Who scratches who? So, quartz is harder than the glass plate. Now, earlier, I was able to scratch talc with my fingernail, which means my fingernail was harder than the talc.
Right.
But if I put quartz on my fingernail,
Uh-oh. Who do you think will scratch who? Oh, let me see if I can get that, mister. Hang on. It doesn't want to focus on your fingernail.
No? Okay.
No, you're blurry.
That's
Sorry.
okay. That's okay. So you can take my word for it. It scratched my fingernail.
Yeah.
So quartz is definitely harder than my finger. So hardness is one property that we use to figure out what kind of mineral something might be. Another common property is something called streak. Streak is the color that a mineral's powder is when we rub it on a tile like this, a porcelain tile. You might have tile like this in your house, maybe in your bathroom or your shower or even your kitchen. This one doesn't have any paint or glaze on it. And we take a mineral like this one I'm holding and I scratch it on there. It leaves a powder behind. In this case, the powder is red, reddish, kind of maroonish. This mineral is an iron mineral called hematite. And hema means red. In fact, the science word for blood is got that in it, doesn't it? Hemoglobin?
Yes.
Yeah.
Hema is actually a Greek word.
Greek word
Yep.
for red.
For red and blood.
There you go. So, not all minerals have the same color streak as their color. So it can be a very useful property.
Hematite actually also comes in silver,
It does.
but the streak is still
It's still
red.
reddish. Yeah. Very cool.
Mm-hmm.
While we were mentioning color, we could talk about color. If you look at all these minerals on the table, we see lots of different colors. Do you think color is a good property to try to identify a mineral by? In the middle here I have all kinds of varieties of quartz. These are all different types of quartz right here. Now when a lot of people think of quartz, they think of crystal quartz. But in our area we don't commonly find crystals of quartz. We mostly find pebbles like this in the stream, which are white, milky quartz. But look, there's pink quartz called rose quartz. Clear quartz is crystal quartz. Purple quartz, amethyst. Black quartz, smoky. Red quartz, jasper. Greenish quartz, opal. So there's a lot of different varieties. So even within one mineral you can have, what do we have, 1, 2, 3, 4, 5, 6, 7, and there's more than this, about 10 different colors for one kind of mineral. So color's not always a great indicator. Also, like if you say to yourself, if you see a purple mineral, it must be amethyst. Well, here's a purple mineral. Here's a purple mineral. Here's a purple mineral. There's 4 different minerals that are the color purple. So color, not always such a great property to use to figure out what a mineral is. Sometimes minerals have what we call special properties, things that are unique about them that make it really easy to identify them. Here's a cool one. Not very exciting looking mineral. It's a type of iron ore, but it has a really amazing property. I have a little car with me today, and the reason I have my little car is it has a magnet on the bottom. Watch what happens. Uh-oh. The car is stuck. Why is that? I also have a regular magnet. The magnet's stuck. This rock, this mineral, is magnetic. Not all minerals, in fact, very few minerals, are magnetic. Even ones that look like metal are not magnetic. So, if you have a little magnet and you have a rock that holds the magnet, it's got to be magnetite. Very special.
That's pretty special.
Yeah. Some minerals come as crystals. Here's a cool crystal of a mineral called calcite. And this one is really clear. It's called Iceland spar. And one of the neat things about it, as far as the property is concerned, is if we put some words like this identification card behind it, I don't think we're going to see this with the camera, but we could try. You end up seeing 2 of every letter.
Yeah, I might be able to take a photograph later.
Yeah.
Do they call it optical calcite as well?
Optical calcite is the common term for it. What happens is, as the light goes through, it gets bent in 2 different directions. And so what you see is 2 of every letter. Almost like it's blurry or
like
distorted.
double vision.
Yeah, double vision. That's a great way to describe it. Iceland spar, special property of that. Optical calcite. Cool. So you guys usually are very excited about crystals. All crystals are minerals, but not all minerals are crystals. Wait a minute, think about that for a second. So if you find a crystal like quartz, it's a mineral, right? But quartz can come as not a crystal. Crystal shape can be something that can help us identify a mineral. Let's look at some common crystal shapes. Here's a cool mineral. It's called galena. It's lead. It's very heavy, very dense, right? But notice the shape. What does it look like? It's got 1, 2, 3, 4, 5, 6 sides. My son likes to play with a little puzzle game that looks like this, called a Rubik's Cube, right? So this is a cubic crystal, like a square, but in 3 dimensions. Another common crystal shape looks like this. This is called a rhombohedron. We just looked at optical calcite is a rhombohedron. Think of it as a cube that's been pushed to the side a little bit. Again, like a rhombus on a piece of paper, but in 3 dimensions. Rhombohedron. Here's a cool crystal shape. This thing looks like you have 2 pyramids stuck on to each other, one on the top and one on the bottom. Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. Can you think of any critters that have 8 of something that might have a name that might help us figure this out? How about an octopus? Octopus has 8 legs, right? Actually, I recently saw something that says an octopus has 6 legs and 2 arms, but that's neither here
That's
nor there.
another video.
Yes. But oct, O-C-T, means 8. So this is an octahedron, or an 8-sided shape. Pretty cool.
Right.
You'll be able to impress your parents with all of your crystal knowledge. Here's another cool crystal shape. And if we were to count all the sides on this, we would see that it has 12 sides. Your parents, if they ever played some role-playing games as a teenager, might have had dice that look like this. Yeah. Things like Dungeons and Dragons.
What do you mean as a teenager?
Oh, you still play
Some of us still play role-playing games.
So 12 sides. So what could possibly be the name for a 12-sided shape? Well, when we count, is it Latin or Greek? When we count in Greek.
In Latin.
In Latin. I always get those two mixed up. When we count in Latin, 10 is deca.
Right.
And 2 is do.
So do.
So
Deca.
12-sided shape is a do, 2, deca, 10. What's 2 plus 10? 12. Dodecahedron. Wow.
Hedron means side.
Yeah, 12 sides, right?
Mm-hmm.
Dodecahedron. 12-sided shape. So cool. So crystal shape. Certain minerals form distinctive crystal shapes. This is one you might be familiar with. This is pyrite, commonly known as fool's gold. And fool's gold forms cubic crystals. It's very distinctive for crystal pyrite. Calcite, we've been talking about calcite a little bit, always forms, well, I shouldn't say always because it has other crystal shapes too, but typically forms in these little squares that are pushed to the side, rhombohedrons. The octahedron is a type of mineral called fluorite. Fluorite's tricky though because it forms these octahedrons, but when they break off from a big piece of fluorite, what's left behind are cubes. So you get two crystal shapes from fluorite, cubic and octahedron. Imagine that breaking out of there. Very cool. Garnet is a common mineral, especially in New York State, and it often forms these little dodecahedron crystals. This looks kind of like a chocolate chip cookie. This is a metamorphic rock. Remember schist? And those are garnet crystals in there. Very cool. So crystal shape is another common property for minerals. All right, so we can use those properties to help us identify one mineral versus another. There's other properties, but that's probably enough on that for today. You ready?
I'm always ready.
Okay, here we go. So now that we've learned a little bit about minerals, we thought we'd talk about some of the minerals here on the table and share with you what they are. And one of the neat things about minerals is we use them for all kinds of things around our homes. They're very useful.
They're very useful.
Yeah.
They're not just decorations.
They're not, well, in our house, they're mostly decorations, but they serve other purposes in our house. But they have uses. So let's go around and maybe you can pick out some of your favorites and talk about them, and I'll share some of mine. And if any of them have uses, we can point it out.
Well, I do know that mica used to be used for windows.
Yes.
They used to take off these layers, which you shouldn't do if you're at somebody's rock display because it's bad manners. But they used to take the layers off, the thin layers, and use them for windows before they knew how to make glass out of mica.
Yeah.
And now there's a substance called vermiculite, which is a mica that they use to make gardening soil lighter and more permeable to water.
Yeah. It's green mica.
It's green mica.
Mica comes in different colors: black, purple, green,
Yeah.
clear. As Ms. Savatgy said, I'll peel off a little piece here.
Which is his, so he can do that.
Mica comes off in these very cool, almost clear pieces. And if you find it in a big rock outcrop, you can get big pieces of this, which pioneers and early settlers did use as windows in their cabins and things. They probably look dirty all the time,
But since that's what they had access to, that's how they let the light
Yeah.
into their places.
yeah. Commonly, when we go to places where there's lots of metamorphic rocks, we can find mica like this. These little pieces, these little sections are called books because it's like pages of a book. Kind of like in a library, huh?
Yeah.
So here's a specimen that has all these little books of mica in it. Very cool.
That's what I know. I do know that there are places in Europe that use selenite for the same purpose, but they had to make sure that the roof of the building came far out because selenite will actually dissolve in water.
Yes.
So they had to make their selenite windows set way back in so they wouldn't get wet.
Protected.
Unprotected. But
So-
they use selenite. Even though it's opaque, it does let in light.
What kind of mineral is selenite? What group? It's a kind of what?
Gypsum.
Gypsum. Yeah.
It's from gypsum.
Yeah,
I
it's a
didn't know
crystal.
there'd be a quiz.
Oh, sorry. I wasn't quizzing you. I was just asking.
It's from gypsum.
Yeah.
But it is not transparent. It is translucent, which means loose is from light. It will let the light in.
When I went on an expedition to the North Pole, I found Superman's Fortress of Solitude.
You did not. You're
That's-
such a liar.
Oh,
You did not find Superman's Fortress of Solitude.
kind of looks like one of those things he uses in
Maybe
his...
it does, but they didn't watch movies in the 80s.
Okay.
But anyway, it does. It was used for there's a church in somewhere near Germany. Don't know where. I have to look it up.
In Europe.
But in Europe, that uses selenite for all of its windows, and it's supposedly one of the most beautiful places.
I'm
So
sure, like optical calcite, when the light goes through here, it does
it's
all kinds
gorgeous,
of cool stuff.
and it's it's the soft white light.
More typically, we find gypsum that looks something like this.
Yeah.
This is just a big hunk of gypsum. It is, somewhat transparent. Gypsum is a very soft mineral too. I can scratch it with my fingernail.
And
So
it's
it's
fireproof, so you'll find it in your wallboard
Exactly.
in your house.
I was going to say, you have gypsum in your house. In fact, most houses, the walls are made out of something called sheetrock, which is ground up gypsum glued between pieces of paper. If I look on the back here, it says United States Gypsum Company, Chicago, Illinois. And if you go to the store, the building store like Lowe's or Home Depot or wherever, I'm not plugging anybody, you buy this in big pieces, big sheets. That's why they call it sheetrock sometimes.
Comes in big sheets.
Yeah. Another cool variety of gypsum is these guys.
They're awesome.
If you go out west into places where it's really dry in the desert or arid, you can find minerals that look like this that are basically crystals of gypsum. They call these desert roses because they look like the flower of a rose, kind of like the petals. Very cool. Gypsum, neat mineral. What else?
What else do we want to talk about?
Anyone you want?
Oh, I don't know.
Well, we were talking earlier about this purple mineral.
Oh, fluorite.
It has these cubes, and it has these, what was this again? 8 sides? Octahedron?
Octahedron.
Yeah.
Your basic 8-sided die. Yeah.
Well, when you grind this up and you put it in something in your bathroom that hopefully you use several times a day, it's one of the main ingredients in toothpaste.
It is. It is. It also comes in lots of different colors, not just purple.
True. You've
Comes in
heard.
yellow and
Yeah.
green, and there's kind of a clearish color too.
Mhm.
Yeah.
You've heard of fluoride, which helps take care of your teeth. Comes from fluoride. Cool.
That's awesome.
Here's a neat mineral. Another property that I don't always recommend to students. You want to do it? It's
No.
called taste.
You do it because you've been doing that.
Taste. Actually, some students do this. So when you taste a mineral, I don't recommend that you take just any old mineral and go up to it and do a big old Scooby-Doo lick on it.
No.
No. Instead, what you could do on certain minerals that you suspect might be something, you just sort of touch it on your tongue.
The tiniest bit. That's a strong one.
It tastes salty.
Yeah.
Wonder why it tastes salty.
Well, I think that's because it's halite.
Yeah, so.
Well, halite is the scientific name for salt.
Oh, it's halite. Halite is the mineral that is salt, right? You grind
right.
this up and you put it in a container like this and take it home and you shake it out, and those little things you see are little pieces of halite.
You can see how old this is because the salt has corroded your container.
So I've had this in my
It's
mineral
powerful
box
salt.
for a while. But one of the neat things about halite is it forms little cubes, cubic crystal shape. And if you happen to have a microscope at home, put some salt under there, what shape do you think it'll be? Will it be all rounded and weird looking? Or do you think it'll have a cubic shape to it?
Yeah, let us know.
If we were at school, I'd let you look through the microscope, and what you'd see is they're all little cubes.
Yeah. No matter how small,
They
you
stay
crunch
as-
that up,
Stay as cubes.
they stay the same shape.
Yeah. Halite is the combination of 2 elements, sodium and chlorine. Together, the science name is sodium chloride.
And what's really interesting is sodium by itself or chlorine by itself would
Poisonous.
kill you.
It's poisonous, yeah. But together,
But together,
it tastes really good on
your
food.
body actually needs them.
Let's get some fries.
Yeah.
Put some salt on.
Put some salt on those.
Some chips.
What else should we talk about?
Oh, here's one. Once in a while, I like to have a can of soda.
I know.
Cans are convenient. You get all kinds of things in cans.
And you can recycle them.
And they're very good to recycle, right?
Yes.
But what do you think? Where do we get our cans from? Some people call this what kind of can?
That's an aluminum.
An aluminum can. Well, aluminum is an ore, kind of like iron is an ore. And it comes from a mineral called bauxite. Just doesn't look terribly exciting.
That doesn't look like aluminum.
Nope, doesn't look like it at all. That's because it's an ore. It has other rocks and things.
Oh, it's all
in there.
mixed up.
Yeah, you have
So how
to
do you
melt
get,
it.
I was going to say, how do you get the aluminum out?
Yeah, they melt it and separate it out. They grind it up first, and then they separate it out, and then they melt it down.
Well, is that like they see sometimes on TV? You see those? They look like big kettles
Yeah.
with a looks like lava inside, but it's not
Yeah,
lava. It's
yeah,
the hot
melted
metal.
Yeah, exactly.
And then they have to pour it out
Yep.
and separate the stuff out of it.
Mhm.
That's what they do with this.
That's what they do with that.
Do they do that with other metals too? Like
They do.
you have another metal over there.
Oh, here's a cool one. This is a mineral that is another example of an element all by itself, just in the solid form. This is copper.
That's copper.
You've probably heard of copper before.
I've heard of copper before.
I was talking to them.
Oh, you were talking about
I hope you've heard of that. And
after 50 years, wow, what's copper?
yeah, it's copper.
It's copper.
We use copper for all sorts of things. One of the common things we use copper for is pipes.
Oh, copper pipes.
Although a lot of people now use plastic for pipes in their
They
homes,
do.
but I bet you if you went under your sink or down in your furnace room somewhere, you might find some copper pipes still. Copper is used for a variety of things. It's really good at conducting electricity.
It is a very good conductor
So,
of heat and electricity.
yeah, if your parents have an old plug-in appliance that they don't want anymore, make sure they don't want it. You could actually cut the wire open, make sure it's not plugged in, or you'll know.
Yeah, ask for their help.
But anyway, you
Ask
could
for those
strip
grown-ups.
the rubber and the plastic off that wire, and what you're going to see underneath there is copper. Strands of copper, which is what the electricity travels through from the outlet to the light or the blender or toaster or whatever it is you're trying to make work.
Yeah, that's very cool.
Copper is a cool mineral.
Very cool. Oh, you know what? I want to tell them something about amethyst that I
Yeah.
learned. That
Go ahead.
I don't know if you know this or not, but I
What
learned.
is amethyst?
Well, it's like I said, I did not know there was going to be a quiz. Amethyst is a kind of quartz, and the purple comes, I believe, from iron impurities.
Yes.
Oh, did I get it right?
You did.
Oh, good. I'm doing good on the quiz.
She's such a wannabe geologist.
But what I learned was, you see how this one's darker? I don't know if you can see it maybe against me better, and this one's lighter. I don't know if you can see them. What I learned was that amethyst will fade in the sunlight. If you keep it in light, the purple color will fade. So if you have a beautiful amethyst specimen, you should not shine bright lights on it to show people or keep it in a sunny window, because the purple color will actually fade, and then it won't be so nice anymore. So that if you have a beautiful purple amethyst, keep it somewhere where it's not so bright, and it will stay beautiful and purple.
Yes.
Did you
Right.
know that or not? Quiz.
I know now.
You know now.
I
Okay.
know now.
Awesome.
Some of the minerals that are really hard are minerals. We talked about quartz. Here's another one. You see those red spots in that rock? That's the mineral garnet, and that's a fairly common mineral that sometimes comes as a crystal, but often just kind of comes in these
And those little globs.
globs. They look, something like this.
Yeah.
Well, garnet's pretty hard, about as hard as quartz. And so if we grind this up into tiny small flakes and do the same with quartz, they glue those flakes onto paper. And they use it,
To be mean to your wife.
no, to sand things. If you have a emery board,
They do use them for emery boards
emery
too.
boards, you can
Yep.
do your nails nice.
I don't have nice nails.
If you do woodworking projects like I like to do when I have time, you use sandpaper to sand off the rough edges of wood, right? So sandpaper, very useful, and all it is ground up pieces of garnet and quartz glued on a piece of paper. Very cool. Anyway, lots of minerals on the table here. Sometimes people come up with common names for minerals that can make it sound a bit confusing.
Yeah.
Here's a really cool mineral.
Quartz crystal.
It is. It's quartz, but people call it a diamond.
Yeah.
It's not a diamond, but it's a kind of quartz that often is very clear. There's another better example here. Let me see if I can hold this up. That one's
That
nice
is
and
so
clear.
tiny.
Yeah. North of here, west of Albany, is
Maybe
a
if you hold
place,
it in front of this.
a place
you can
called
see it.
Herkimer, New York.
Yeah.
And some of you may have been lucky enough to go to Herkimer, New York, and you can go to these places where you go in and you pay a little bit of money, and then all around you are these big gray rocks everywhere that look like this.
Yeah.
And they give you goggles and hammers and things, and you go in there and you bang on the rocks. And sometimes when you bang on the rocks and you open them up, you find these little cool crystals of quartz sitting inside of the rock, called Herkimer diamonds, but really they're quartz
They're
crystals.
quartz crystals. Yep. They're just known for their clarity and beauty.
Yeah, they're great for jewelry. A lot of kids ask, are they valuable? Not so much. I mean, some of these minerals, if you bought them at a mineral shop, might be, $30, $40, or $50, but they're not like diamonds. They're not worth thousands or tens of thousands of dollars. Here's a whole bottle full of little Herkimer diamonds. You could use these in jewelry and making necklaces or rings or whatever. They're very cool.
Yeah, a lot of these came from yard sales or other collectors, or we traded, or you found these.
It's funny, I was going to say, a lot of kids say, where'd you get all this stuff? Well, so I went to school to be a geologist, and for the last, what would you say, 35 years?
Yeah.
Maybe a little bit longer. Even before I knew you, I was collecting rocks and minerals. Some I find out in the woods or on trips to special places where these minerals occur. Others I go on vacation with my family, and we always tend to end up in places called rock shops, which are like little boutiques that have nothing but minerals and rocks and fossils, which are awesome. Believe it or not, I found several things at yard sales or flea markets. Someone else had a rock collection and they didn't want it anymore. They had some cool minerals and they were selling them. So this is, believe it or not, just a little bit of my mineral collection.
Yeah, there's a lot more.
Yeah, yeah. I usually like to collect big minerals and big rocks to put in your garden so that it's pretty.
Yeah, we have a lot of big specimens. We collect things on walks. We go to places where they're known for fossils or minerals or whatever as part of an outdoor vacation.
Hey, what if they wanted to start a mineral collection? What could they do?
Well, that's what I was just going to say. I mean, you can do this. You can start right now collecting things in our area, or you can look at yard sales, or you can ask family members to, you can put this on your birthday list if you're interested in this stuff, because you did that.
Yep.
Or you wanted this kind of fossil or this kind of specimen, and we did that. And if you don't have anything to collect them in, but your family eats eggs, you can save an egg carton and start an egg carton collection. So we've put together kind of an example here for you of an egg carton collection you can start, and you can just put one in each spot, and then up here you can make a paper that says what each one is, and maybe where you got it or who gave it to you. You could do that, and then when you fill up one egg carton, you can go to the next and start that way. Another thing that works really well is sort of they have like fishing boxes where you put lures in, and those work really well. We have a few of those that were given to us, and then we made a few of those for the school.
Little organizer trays for crafts and things. You can get it in Michael's or the craft store joints.
Right.
They work great.
Or those ones with the drawers, and they work really well too, depending on how many you have. They work pretty well, but this size specimen is a good size to start with. That's a good size to start with. They're inexpensive, and you can get a lot of different kinds of things. And you can also just collect really cool specimens that you find and do it that way. So we're gonna have to wrap up
we're good.
our
So-
stuff here, but
So one last question. So they want to be a geologist. They've learned everything we're talking about. They're starting their collection, but they can't figure out what they have. Where could they look?
well, there's books for that.
Oh,
There are field guides that they could look at. You can get these in the library. You can look in a field guide like this. You can look in the library, and if we're still distance learning, you can actually find stuff like this online. You can contact me, and I will send you resources to take a look at that stuff. And I'd be happy to help, because we got help. And also, we're going to be having some meets about that, so you can join in on those meets. So we'll be happy to see you there. So have all the fun.
Bye, boys and girls. I hope you have a great time learning about minerals and maybe starting your own mineral collection.
That would be super. So do all the good out there, have all the fun, and have a great time.
See
And
you
I'll
next
check
time.
you later.
Hey, you're pretty knowledgeable about minerals.
Am
Yeah.
I? Really?
I have no more questions for you.
I passed the test. Yay!
An 80.
I got more than an 80, dude.
Yes. All right. Our meeting already started.
Our
so-